I'm Math Dad.
I'm Science Mom.
Today we're talking about fractions and mixed numbers. So there are different ways of writing fractions beyond what we've talked about before.
Don't forget that there is a worksheet in the description so that you can do these problems with us as we go through them. And if you would like more details and practice with fractions, we have a link to a Fraction Ninja Bootcamp in the description as well.
And today we're going to be going through lots of examples. The best way for you to learn this is to pause the video and try the problems yourself, or to try those worksheets in advance. All right, we want to write this fraction as a mixed number. So 22 thirds, or 22 divided by 3. And to describe what a mixed number is, we're just going to do long division. We want to write it as a whole number plus a fractional part. So 22 divided by 3, do you remember how many times 3 goes into 22?
Well, 3 times 7 is 21, so it'll go in 7 times, but then we're going to have a little bit left over.
7 times with a remainder of 1. So 7 and 1/3 is the mixed number form of this fraction, 22 thirds. And they actually even used to give these a different name. They would call them improper fractions.
Improper?
Yep, as though there was something improper about 22 over 3, a bigger number on top. Usually the numerator's smaller than the denominator when we think about fractions. And I always envision some Victorian age old lady saying, improper fractions. So to visualize this, we're going to imagine having pizzas that are cut into thirds.
7 pizzas? No, there are 8 pizzas there.
There are 8 pizzas because there are 7 full pizzas, plus we need a little bit more of one pizza. So let's count this out. So I got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22 slices of pizza.
Ooh.
So there's 22 of the slices of pizza that are of size 1/3 of a pizza. So 22 thirds. But if you want to think of it as a mixed number, well, that's 7 full pizzas plus 1/3 of another pizza. So either way, they both represent the same things. So if I were to ask you, wow, how much pizza did you eat? I think in this instance, saying, well, 7 and 1/3 is a more descriptive and maybe useful way of thinking about it. But you could also say, all right, 22 slices that were 1/3 of the pizza, and that would also carry the same information. 48 divided by 9. Ooh. So if we were to break out long division, so we'd say, all right, 9 is going into 48. Well, 9 doesn't go into 4, 9 goes into 48. Well, 5 times, 9 times 5 is 45. Subtract, and the leftovers are 3. So in the past, when we would do 48 divided by 9, we would say, oh, well, that's 5, remainder 3. So when we're doing our long division problems. But in this case, so it's 5 with 3 parts left over, that's going to help us write this as a mixed number. It's 5 and 3 parts out of 9. Yeah, so 5 and 3/9. Now, that's actually not in its simplest form, so let's take a moment. 3/9. We can rewrite the fraction 3/9. So that's 5, and if we take that 3/9 and divide by 3 on top and bottom, we would get 1/3. So 5 and 1/3. So remember, pause the video and try these problems on your own. It's okay to watch us do it, but I think you'll learn so much more if you try these yourself. 77 divided by 5.
How do I write that as a mixed number?
Mm-hmm.
Well, I can divide with long division.
Okay, so I think long division is our best tool here. So 5 goes into 7.
1 time, and 1 times 5 is 5, and if I subtract 5 from 7, I get a 2.
Okay.
And 5 does not go into 2. I bring down the 7.
Good.
5 goes into 27 5 times.
Aha. So 5 times 5 is 25. We subtract, and there's 2 left over. All right, so 77 divided by 5 is
5 and 2/5.
15.
Oh, sorry.
That's okay. And then 2 parts out of the 5 are left over, so 15 and 2/5. We want to write the fraction 111 divided by 6 as a mixed number. And our technique for getting there is to use long division. So 6 goes into 111. how many times? Well, 6 doesn't go into 1. Does 6 go into 11?
Yes, 1 time. 6 times 1 is 6. And then when we subtract 6 from 11, we're going to get 5.
Okay.
Sorry, I did not say that very clearly.
I understood you. All right.
Oh, good.
So then 6 goes into 51 how many times? So 6 times 8?
Yeah, 6 times 8 is 48.
48.
That's as close as we can get.
Oh. And then we subtract, we're left with 3. So altogether, 6 went into 111 18 times with 3 parts out of the 6 left over.
Ooh, and I recognize that 3 divided by 6 is the same as 1/2.
That is correct. So we could write this as 18 and a half, and that would be the simplest form of our mixed number. So both representations of the fraction are useful to us. Sometimes we like the mixed number version, and sometimes we like just the fractional version, or the improper fraction. Ooh, 592 divided by 8. How do we write that as a mixed number?
Long division.
Long division is indeed our technique. So 8 goes into 0 times. Okay, so 59.
7, because 7 times 8 is 56.
Very good. So the leftovers are 3. I'll bring down my 2. 8 goes into 32. 4 times. Yep, exactly 4 times. Wait a minute. It goes exactly 4 times. There's nothing left over.
No remainder.
So to write that fraction as a mixed number, well, it's actually just the number 74. We could do 74 and 0/8 if we really wanted to, but that would be kind of silly. 74 is a perfectly good number on its own. Okay, 1,000 divided by 12. Ooh, so this is a review in long division. So 12 is going to go into 1,000. Well, 12 doesn't go into 1. 12 doesn't go into 10. So how many times does 12 go into 100?
Let's see. 8 times 12?
8 times, yep. 8 times 12 is 96. Subtract, it's 4 left over, and we bring down 0. Okay, does 12 go into 40?
Yes, 3 times, because 3 times 12 is 36.
I like it. Subtract, and our leftovers are 4, and 12 doesn't go into 4. So 83 remainder 4, or we would write our answer here then as 83 and
4/12.
4/12. But is that the simplest form?
That is not, because if we divide 4 by 4, we get 1, and if we divide 12 by 4, we get 3. So 83 and 1/3.
83 and 1/3 is correct. We always want to write our answer in this simplest form whenever possible. Remember to pause the video and try these problems on your own so you'll learn as much as possible. All right, 82,936 divided by 10.
Ooh.
So it turns out division by 10 is not too hard, especially once you've learned decimals. We haven't talked about decimals yet, so we're not going to get into that. We're going to go ahead and just do the long division, but we'll take a look at the answer once we've got it. So 10 is going into 82,936. 10 goes into 8 0 times. It goes into 82.
8 times.
All right.
8 times 10 is 80.
All right. We subtract, bring down the 2, and I'll bring down a next number, 9, or I could bring down all of them. 10 goes into 29.
20 times, 2 times.
2
times
times.
10 is 20.
Yep. Okay. We subtract with the 9 left over then. Okay. 10 goes into 93 once we brought the 3 down.
9 times.
9 times. Okay. So it's 90. We subtract. That leaves us with a 3. So 36. Uh-oh, we're running out of room. 10 goes into 36.
3 times.
3 times. And, uh-oh, on bottom, if I fit a 30 in there and subtract, I'm left with a 6. Just use our imagination there. Okay, so we got 8,293 with a remainder of 6.
6 over 10.
6 over 10. So 6 parts out of 10. And we need to simplify that, but before we do, I just want to point out 8, 2, 9, 3, and 6. Those are the same numbers there.
Ooh.
That will happen every time when you divide by 10. You're really moving the digits over one place value. And when we get to decimals, it's a super powerful tool for visualizing just such calculations. All right, so to simplify this, we have 8,293, and 6/10 is not the simplest form of that fraction because there's a common factor for the top and bottom.
They can both be divided by 2. 6 divided by 2 is 3. 10 divided by 2 is 5.
Very nice. There we are. There's our mixed number. All right, a riddle here for you, Science Mom. Kate's mother has 3 children. Snap, crackle, and...
Pop. Just like the Rice Krispie commercial.
Nope, you're wrong.
Snap, crackle, and stomp. I don't know what.
Kate.
Kate?
Snap, crackle, and Kate. Because it's Kate's mother. Kate's mother has 3 children.
Oh, that's rather clever. I like it.
Okay, now we're going to go in the reverse direction. We're going to start with a mixed number, and then we want to end up with a fraction. And you might be wondering, so why would we want to go in that direction? Because often the mixed number is the simplest one, or the one that we have the most intuition for, but it turns out that the fraction form is easier to do a lot of calculations with. So we need to be comfortable with both forms. All right, so to convert a mixed number to a fraction, we could try to think of the picture visually. So going back to our pizzas, we've got 13 whole pizzas plus half of a pizza. Let's draw that out. There we are. I've drawn 13 and a half pizzas, and we could ask ourselves, well, how many half pizzas are there? We could count it up one at a time here. So we get 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27. That's a lot of half pizzas.
It is, but it's easier just to say, well, 13 times 2.
Ooh, Science Mom for the win here. She's exactly right. Rather than count all those pizzas, we could just say, well, there were 13 of them, each cut into 2 slices. So 13 times 2 is 26, and then we just have to add the next pizza on. What we said was we should do 13 times 2 plus the 1, all divided by 2. So that was 26 plus 1 divided by 2 for a grand total of 27 divided by 2. 27 halves. So the conversion to from a mixed number to a fraction will work this way every time. We can multiply the whole number part by the denominator and then add that to the numerator, and that gives us our new numerator. Let me say that one more time. We multiply the whole number part by the denominator, and then we add the numerator. That will give us the new numerator of our fraction. All right, 11 and 2/5. That's a mixed number. How do we write it as a fraction? We don't want to draw a picture each time, so let's follow the procedure that we just outlined. So
11 times 5
So 11 times 5 is,
is 55.
55 plus 2 more, all divided by 5. So this will get us our answer. So 11 times 5 is 55
plus
2. So altogether, that's 57 divided by 2. And I'm being very careful with my equal signs. I can trace my work forward or backward each step and know exactly what I accomplished. I don't have to guess what I did. My teacher doesn't have to guess what I did. Everyone's happy when we communicate like that. So what we're going to do this time is rewrite the number 11. So how many fifths are there in the number 11? Let's think about it in pizza slices. If I had 11 pizzas and I cut them into 5 slices each, how many total slices would there be?
Ooh, 11 times 5.
That's right, so 55. But now 55 divided by 5, because there were 5 slices per pizza. That's one way of rewriting the number 11. Aha! So now we have 55 fifths, but we also had 2 fifths.
Ooh.
So altogether, how many fifths do we have? If we had 55 fifths and 2 fifths,
57 fifths.
we have a total of 57 fifths. And that's what's going on here. That's what was accomplished by this algorithm here. All right, 6 and 9/11. Are you ready, Science Mom?
I'm ready. Is it my turn?
You're in.
Okay. So if I have 6 pizzas and they're each cut into 11 slices, oh boy.
Yeah, I don't know if you want to go with the pizza route, Science Mom.
Yeah, that's going to be a mess. But I can think that the way to count how many slices there are, I just need to do 6 times 11, which gives me 66. That's how many 11ths I have in total with all these pizzas or pumpkin pies. But I also have a fraction. I also have most of a pie, 9 11ths. So I do 66 11ths plus 9 11ths, and that gets me 75 11ths. That is my answer.
That's right, 75 11ths. And I will point out, whether we do the picture or not, we can just follow the rule. So the rule I gave us was we multiply the whole number part by the denominator. So that was 6 times 11 plus the numerator, and then we just keep the denominator as it was. So 6 times 11 is 66 plus 9 all over 11, and then 66 plus 9 we can replace with 75.
Very nice.
25 and 3/4.
All right, I'm going to try it with the rule this time. So 25 times 4 plus 3 all divided by 4. That's what I want to do because I am taking this whole number times the denominator and then adding the numerator. Now, 25 times 4 is going to be a big number. I like to just think of quarters. If I have 4 quarters, that equals $1. So 100 plus 3 divided by 4 is 103 divided by 4.
Beautiful. There's only one thing you could have done any better here, Science Mom, and that would be to write an equal sign right there.
Oh.
Now, 103/4. 8 and 4/9. We want to write that as a fraction.
Don't forget to pause the video and try it yourself before you see us do the solution. So 8 times 9 plus 4 all divided by 9 is another way that I can write this.
Okay.
8 times 9 is 72 plus 4 is 76.
All right, 76/9. That is correct. So we're able to convert a mixed number to a fraction. We're able to convert in both directions now. And I just wanted to remind everyone one more time what is going on here. It's not magic. We're just following the procedure. We're writing the number 8 as 72 divided by 9. And then we're adding that to 4/9. So 72/9 plus 4/9 would be 76/9. 22 and 1/6.
All right.
Can she do it?
So if I have 22 pumpkin pies and they're each cut into 6 slices, how do I find out how many slices I have in total? Well, 22 times 6. But then I don't want to just have that pie. I want to make sure that I include this pie slice. So I'm going to add 1. And then the thing I'm talking about is pie slices. So
sixths of a pie. Yep.
keep that denominator the same. So then I just need to do my multiplication and addition. 22 times 6, oh.
Well, one way you could think about it, 22 times 6 is the same as 11 times 12. So I take half of the 22, but I double the 6. It's 132.
Thank you, Math Dad. 132 plus 1 all divided by 6 equals 133 sixths.
There you go. You've converted from a mixed number to a fraction.
Woohoo!
Thank you so much to our patrons who support us in making these videos. We could not do this without your support.
If you'd like to join our Patreon family, go to patreon.com/sciencemom and sign up.
Work hard, grow smart, and we'll see you next time.